And welcome back, everybody. For those of you that have been watching the Weather and Climate Summit here at Breckenridge Online, I am Dave Jones. I'm one of the co-organizers of the Weather and Climate Summit out here at Breckenridge. And we're trying something very new. We have never done this at a Weather and Climate Summit before. We're bringing back the speakers from the morning session, and those speakers can then answer direct questions from you out in any part of the world that you may be connected from. So we have just a couple of ground rules. One of the ground rules is we would like you to identify where you're asking your question from. Are you in Los Angeles? Are you in Washington, D.C.? Are you in Norman, Oklahoma? We'd like to know that. And then Sarah Maxwell, who is our social media streaming expert here, will then read out the questions that you ask online. And we have Paul Schlatter from the National Weather Service and Don Burgess, who both spoke about dual polarized Doppler radar. So I'm going to turn it over. Sarah, you don't have a microphone, but Robert, can you hand Sarah the microphone that you that I just handed you, and then Sarah can ask the questions that she sees online. So the first thing, before we go to any questions, Don and Paul started talking about something interesting before we went live, and I said, "Hey, hold on to that. That was a great question. I think some folks might like to hear that." So, Paul, go ahead and ask that question of Don.
Yeah. So the question is, someone in Paducah was asking, okay, so where and when did the term debris ball first come about?
I've done a search on this recently because I had a question from a friend, Ron Prisbalinski from the St. Louis Weather Service office. And there is an old-time paper from the early 1960s. Authors' names are Garrett and Rockney, where they saw what we now call a debris ball in reflectivity. They called it an ASC, A-S-C, and they attribute it to possibly being associated with debris, but so they identified it, but they didn't call it debris ball. Then the second paper is one that I did with co-authors looking at data from the May 3rd, 1999 tornado in central Oklahoma in Weather and Forecasting, the special issue on May 3rd, where we called it reflectivity ball, and we definitely attributed it to reflectivity and studied it. But to transition from debris ball to reflectivity ball, that has not occurred till the last couple of years, and it has appeared in a number of places almost simultaneously.
Interesting.
That sounds great. Well, thanks very much, Don. And let me just ask you, just for the audio, when you're answering, just try to hold the microphone a little bit closer to your mouth, just so we can get a good picture. So I'll turn it over to Sarah Maxwell. I think she has an online question that she'd like to pose.
Okay, can you hear me? Okay, great. This question comes from Josh Trostel from the Severe Storms Research Center at Georgia Tech Research Institute. He has a question about the microwave backscatter results from the C clutter, and he's wondering if it indicates, in general, that the HH returns are higher than the VV returns for low grazing angles, which may explain the areas seen in just offshore stuff in your presentation.
And you can look at that camera when you answer that one straight ahead there.
Oh, straight ahead, okay. Don, you want to take that one?
Well, I don't feel very knowledgeable to answer this question, but it's entirely possible that the vertical dimension of the sea spray might have some characteristic that allows it to be a larger dimension than we would expect for most precipitation-sized drops. Also possible that these are very small drops and the wind literally rips them apart, which could create different shapes than we're accustomed to seeing. But in the end, I'm afraid that I cannot easily answer the question posed. Maybe, Paul, you can take a shot at it.
Right, and just because we've seen negative ZDR, significantly negative differential reflectivity associated with these signatures offshore, either the west coast or the east coast, suggests that yes, the vertical channel for some reason dominates the horizontal reflectivity. But as to why, that's research is going to have to find or understand better how that might come about.
Hi guys, this is Jennifer Rocavina, the Chief Met at WPSD in Paducah, Kentucky, and I have a viewer question from Justin Adams, who works with International Emergency Management in the energy sector. And his question is, with dual pole radar, do they think it will reduce false positives on warnings, on warning TDS cells, giving Metro a better view of the storm?
Well, if we're talking about reducing false alarms in tornado warnings, I don't think that at least initially dual pole is going to have a strong input to be able to do that, because the dual pole signatures we're seeing for tornadoes occur after formation. We want to issue that warning well before the tornado forms to give people time to take shelter. So we're going to continue to have to use the tools that we currently have now: radar data, velocity data, seeing the circulation form within the cloud, and spotter reports that conditions are getting right for tornadoes, and try to anticipate the time of tornado formation.
Yeah, and where it'll also help is people further down the path. So, in other words, a tornado warning goes out based on the normal reflectivity and velocity signatures. When later on, if we see debris form with that particular signature, people further down the path, we're able to give them that message that, hey, this is a damaging, it's confirmed tornado. Immediate action is required. It's a much stronger statement than just saying we think there's a tornado in there or a tornado is possible.
And so just a further conversation, I don't have any other viewer questions, but for the conversation itself, and I think taking away from today is one of the benefits to this upgrade is certainly seeing a better confirmation, if you will, that there is a serious threat, as opposed to, well, this storm hasn't produced anything significant yet, so that might cut down on TV time, interruptions, and that sort of thing, but also verifying, especially overnight when you don't have spotters that can verify for you that there may be debris and possibly a tornado on the ground. Also, in a lot of different areas, you've got in the wintertime regions that are on that rain, sleet, snow line. Discuss a little bit with me how this advances determining when that switches over and how it may give a little bit of lead time as to where snow banding may set up.
Right, so with current radar technology, what we call reflectivity, that's what you see on television all the time. It's the greens, the yellows, the reds. With that technology, the older technology, we're only able to tell whether precipitation is increasing or is heavy, but we are unable to discern with that radar whether it's rain, whether it's snow, whether it's a mixture of precipitation. With dual polarization technology, we have the ability to identify where it's rain and where it's snow and then track that, particularly if you're close to the radar, i.e. in a major metro area near a radar site. We're able to track where that transition zone occurs, and so every 5 minutes we're getting an updated position on where it's going from rain to snow or maybe even to sleet. And then that can give a heads up to people who are traveling, to airports, to road crews who need to treat the streets so that they know when things change over to snow. So a lot of neat things that are coming with dual polarization in terms of winter weather.
Do you want to also discuss some of the drawbacks, some things that just quite aren't there yet? I know, Don, you were discussing a few of those things and how this is still in an infant stage and that this is all new technology and there are things to work out.
Yes, we're still working on basic issues with the radar. Calibration is very important, and like with any new technology, we have to work on getting all of the calibrations right and getting all the radars tuned. And so we're still at work on that. A lot of the things that we've talked about, a lot of the things that Paul has talked about, we can get from the variables themselves, a lot of important information. But some additional information, for instance, precipitation accumulation estimates, we need some algorithms to help us, and we're working on finishing and maturing those algorithms so that they give the right answer a vast majority of the time.
Paul, this is Dave Jones. I have one question that I wanted to pose to you, and that is, how does the dual polarization or the dual pole Doppler radars fit into the overall initiative of the Weather Ready Nation from the National Weather Service?
Right, so with the Weather Ready Nation, we're trying to prepare or help our customers make better decisions. we're empowering them with information and more accurate data at their fingertips that then they can use and make the decisions that need to prevent or protect lives and livelihoods. With dual polarization technology, that's one of the tools available to National Weather Service forecasters that mainly will increase forecaster confidence in the things that they're seeing on radar, which how that helps is it translates into more accurate products, more confidence in the products that they are issuing to the American public and all of our partners. And so it piggybacks on with a broadcast meteorologist, where if we're adding more confidence to our products, then they see that confidence and they can translate it into a much stronger message to their viewers. And so for Weather Ready Nation, it's all about empowering people to make better decisions, have better data at their fingertips to make those decisions.
We're going to increase communication, and that's always going to be useful, and it will help to make us all weather ready.
Don, just out of my interest too, I know I think I'm right in that you used for the first time dual pol in some of the Vortex and on Doppler on wheels. Is that right? Is that how this was kind of born?
Well, several of our mobile radars had dual polarization, but actually it's been in research for fixed-base radars for 20 years now, 20 to 25 years. So we've transferred it to mobile radars, but the first applications were fixed-base radars.
And what are some of the successes that you had in the Vortex project? Maybe some of the realizations, some of the data that came back that was successful for you?
Well, we've learned with these mobile radars, dual polarization equipped. Now these are X-band and C-band, 3 centimeter and 5 centimeter wavelengths. And they have a couple of additional issues we have to work through, like attenuation. We are working through those issues. But we've learned with those radars up close to the storm, we can see a lot of detail, even more detail in the debris signature that Paul and I talked about, and more detail about the distribution of precipitation particles, drop sizes, and hail. And in Vortex II in particular, we had mobile mesonet teams driving up underneath the storm, driving into the hail. So we had very good verification on the hail data, and gives us even more confidence in dual polarization that it's working correctly when we get such good verification data.
So are we going to see any more Vortex, maybe a Vortex III? Is that coming up anytime soon?
I'm sure you're going to see a Vortex III, but not anytime soon for a couple of reasons. First, big experiments are expensive, and for our part of the severe storm community can probably only be afforded about once a decade. Such was the case between Vortex I, Vortex II. I anticipate that for Vortex III. Second reason it still needs to be a while is good money was paid to collect a lot of data, and we need to analyze, go through that data, and learn from that data before we go out and collect more data. So we might have smaller, more focused efforts in upcoming years, but I don't think you're going to see a Vortex III for quite a few years yet.
We're just checking for any more online questions. So those of you that are watching, if you have any other questions, please submit them now, and we can pose them to Paul and or Don. We'll give it another minute or two and see if anybody has any.
What your background is so that anyone that's just coming in knows more about you.
All right, we can do that. My background is severe storms, many years at the National Severe Storms Laboratory, research, radar. I was fortunate enough to be involved in the development of Doppler radar and NextRad, and have been able to continue that over time. I've had some involvement with training, some involvement with the administrative parts of this and the management program. But I'm now retired from the federal government, working for the University of Oklahoma, a cooperative institute back with NOAA, and trying to again work on the research side.
And so my specialty was in radar meteorology as well, but more I was in training in the National Weather Service for the past 8 years. And so my focus was taking the interpretation of radar data and how that would translate into benefits or better, more accurate forecasts and warnings from the National Weather Service. So I did that for the past 8 years. Loved doing it. I made a career change just in April. Now I'm an executive advisor for the director of the National Weather Service, Jack Hayes. And he's been using me for severe weather, for radar, just developing policy and helping him understand the intricacies that are involved with severe weather warnings, and especially given the 2011 that we all had, right, with the severe weather and the tornadoes and that kind of thing. So it was a good year for me to be downtown as an advisor.
Dave, I was going to comment that I might answer a question that was posed this morning, and one to which I didn't know the answer when it was posed by some of the people in the audience. And that question concerned the Ridge software. This Ridge software is used by the Weather Service on their websites to display radar data from the WSR-88Ds. And many people have seen it on those websites. The question was, when will the Ridge be updated to include dual polarization outputs? And I was able to find the answer, and the plan is for that upgrade, but not until all of the sites have been implemented. So we're perhaps a year or a little more away from that upgrade right now.
I do have one follow-up question to that, Don, and perhaps Paul too. When you see the national mosaic of the radar, when you go to the Weather Service website and you see the national mosaic, does that mean that dual pol data won't make it into that national mosaic until all of the radars are together or dual polarized?
I think when you look at individual sites in the base data, you won't see dual pol outputs. But when you look at the regional reflectivity mosaics, dual polarization is already being used there as a background to edit and quality control so that we get precipitation outputs and not non-precipitation outputs being displayed.
So oftentimes when you do look at the national mosaic of the radar, you do see a lot of, typically called ground clutter around those sites. When the sun goes down, you have inversions, all that kind of stuff. Are you saying that the dual poles, when they come online, will be used to help minimize that? So we'll slowly see that ground clutter go away in the national mosaic?
Yes, over time you will see that occur. Now there's some software stages, and this will be done in steps and increments, but there's already some being done now, and more will be done in the future. I might point out that we're probably going to see two kinds of radar displays for the future. One that's just the precipitation, and many people want to see just that. But then we might also want to see displays that have the precipitation and the clear air data, because there are boundaries in the clear air data, not precip, but thin lines with gust fronts and other important features. And some users of the radar data want to see those as well. So I think we'll see two types of radar outputs.
One final question that relates to when we had a weather and climate summit a few years ago now that I experienced personally, and that was when we were flying into the Steamboat area in northwest Colorado. We were at about 34,000 feet and encountered a horizontal roll vortex from a lee wave. It was a very strong surface winds in Boulder. They were experiencing 90-mile-an-hour winds at that time. We were flying at 34,000 feet. We dropped 9,800 feet in a minute, and then the pilot, gunned the engines a little bit, and we went back up 10,000 feet in less than a minute. There was a lot of screaming on the plane. People didn't have their seatbelts on, and it was, this clear air turbulence. And I'm wondering if dual pol radar or any technology that's coming up from the National Weather Service might help to detect that, because the pilots were totally unaware. As a passenger and a meteorologist, I was looking out the window seeing these massive lenticular clouds, and I was like, told my family to put their seatbelts on. But how do we address this kind of issue?
Well, the radars themselves it would be a tough job for them to be able to detect clear air turbulence, just because for radars to detect anything and get a strong enough signal to create accurate or good radar products, you need some strong scatterers, like raindrops or ice crystals or things like that. And a lot of times in clear air turbulence, that's just it. It's clear air. And so it's a tough sell for radars to be able to detect that kind of stuff. But I don't know, are there any other observation platforms that might help with that?
Well, I don't know of anything particular in dual pole that's going to
Right,
help.
yeah.
And Paul's absolutely correct that the problem in the clear air is no scatterers. But there are clear air returns close to the radar, and there are occasionally strong refractive index gradient changes even in the middle part of the atmosphere that maybe a little bit of that can be sensed. But actually the better opportunity would be more advanced radar on board the aircraft, because their clear air return ahead of them should be, with a properly configured radar, enough that they might be able to sense that. Now, having said all that, one other plug I want to put in here is that we are about to implement a turbulence algorithm for the WSRAD-8D, and those outputs will be coming in the next couple of years. Again, with the caveats we've already said, can't see everything in the clear air, but it will take the spectrum width and other inputs, and it will actually calculate the magnitude of the turbulence.
That's terrific and very informative. And we did have a note from one of the online viewers saying, please thank the speakers for coming back this afternoon, because they're really learning a lot. And we have quite a few people that are watching right now. So for those of you who just wanted to sit and listen, thank you for doing that. And thank you for your input and everything. Paul and Don, thank you so much for coming back. And we hope that others tap into your expertise while you're here at the Glenn Gerberg Weather and Climate Summit out here at Breckenridge. So with that, we will end this this first session, this test session of the first day of the Weather and Climate Summit, and we'll see you back here for the same session with a few more speakers tomorrow. And please join us tomorrow morning as we begin streaming once again with Dale Eck from the Weather Channel with his daily weather briefing. That will start at 8 o'clock in the morning. Tomorrow morning, and these times are Mountain Standard Time, so please make your adjustments accordingly. And you see the schedule up there. From 8:30 to 9:45, we'll have Dr. Greg Forbes from the Weather Channel, and his topic will be the deadly 2011 severe weather and lessons learned. Then Bruce Thomas will join us from Midland Radio. Bruce is a former television meteorologist who is now the spokesperson for Midland Radio. And he's going to talk about the importance of having a NOAA weather radio, especially with all the severe weather that seems to be increasing around the country. That's going to be a short presentation, about 15 minutes, and then we'll move on after a break to Dan Leonard from WSI, who will talk about seasonal forecasting. How is that possible? We've talked quite a bit about the challenges of short-term forecasting and using dual-pole Doppler radar to really get down into details for a minute ahead to 5 minutes ahead. And we're going to jump tomorrow afternoon in the second session to seasonal forecasting. How can we see what the weather is going to be like, or the climate is going to be like over the next 6 months to maybe even a year. So that should be very interesting. And then we'll have those speakers back to join us for a live question and answer session from 1:30 to 2 o'clock. So thank you very much for joining us. I'm Dave Jones with the Weather and Climate Summit. We'll see you again tomorrow morning. Thank you for joining us.